Everyone, today we will learn about the system designs, and I'm sharing here my system design notes from the basic to advanced. Let's start with that. First of all, we have to know the system design basics. In the system designs, what we have to do first, we have to try to break the problem into simpler models, top-down approach. Second, we have talk about the trades-off. Like we know, starting, not any software or not any solution is perfect. We have to make it perfect. For that, we have to keep such thing in our mind when we are trying to creating any system or any software application. So calculate the impact on the system based on all the constraint and the end test cases. I divided this 3-4 section which we have to keep in mind. And first is like scope the problem. Second, we have abstract design. Third, we have a finding and addressing the bottlenecks. Bottlenecks means we have to find the problems when the request is getting increased. Then finding and addressing bottlenecks. Bottlenecks like when we have to be saying when the request is going increased at a certain level, then what we have to be doing, how we are handling. So such type of problem we have to be take in mind. Scope the problems. In this we have to be asked question about the constraint, functionality, requirement, and all the stuff we have to be keep, but have to be focused on the interviewer's intentions. In the system design basics, we have to be like first architectural pieces, resource available, then have to be like how this resource and work together. Third, with utilization and trades off. For that we have to be check mark like this consistent hashing, cap theorem, load balancing, queues, caching, replication, SQL versus NoSQL, indexes, proxies, data partitioning. So all this constraint and entity I can say we have to be keep in mind while designing the system. So these all the tips, these all the topics we have to be keep in mind while creating the system design. In the load balancing nothing but it is like distributing our server for when we have a lots of requests going certain time to increase like a live when we are watching the live data from the like match or from some other like live concert, then the upcoming request is getting high at certain level. So how we have to be manage such type of request when data certainly increased at the peak of time. So for that purpose this load balancing coming in a scenario to distribute the server when getting the lots of requests. And we have a algorithm or we have a types of distribution for the load balancing. It is comes under random and round robin and random. Random is like we have to wait for the memory and CPU cycle. Then we have to be utilize the full scalability and redundancy. For that purpose we have to be add the 3 load balancer. First load balancer we have to be add between the user and web server. Then we have a web server to app server. In that we have to again second load balancer, and what we have an internal platform from that to our database there will be a third load balancer. So according that we have to be add 3 load balancer for the full scalability and redundancy. The architecture here we have this client, and this client request is going to the web server. From that we have added the one load balancer. Then again from the web server to our app server again we added the load balancer, and reaching to the database from app server to database server we added the one again load balancer. So according that we are added the 3 load balancer for scalability and performance increasing purpose. And after that we have a smart client. Smart client is like take a pool of services, host and balance load. It used for the like detecting the host that are not responsive. Client is like as an end user I can say. And second we have a recover host, and third we have addition of the new host. So load balancing functionality is to like to 2 dB I can say we have a more attractive point for the developer perspective. It is like small scale system. As system grow the load balancer stand alone the server. So when the certainly the request is going high, then this load balancer is a very important thing to add in the system to balancing the request and distributed the request into different server. After that we have a hardware load balancer. Hardware load balancer is expensive but high performance. Example like Citrix NetScaler. It is now travel to configure, but it is like expensive, but yeah it is going to increase the performance. When we know like in the normal days we have a like normal mobile phone, when we have a high RAM or in my CPU or in my laptop a high RAM, so it will be giving the high performance. Similarly, in the request also, in the system also, we have to check this type of thing. Large company trying to avoid this configuration or use it at first point of contact to their system to serve as a user request. This is a very high, so most of the company trying to avoid this type of configuration because of the cost cutting. Intra-network uses the smart client and hybrid solution for the load balancer traffic. Coming to the after the hardware load balancer, then we have a software load balancer. In this, no pain of creation of the smart client, no cost of purchasing the dedicated hardware in the software load balancer. It is like hybrid approach, and example like HA proxy OSS load balancer, one of the example, and software load balancer coming under the client and server. It is managed between these two and managed by HA proxy with the efficient management of request on the port. It is traversing or transferring on the some request for the particular port and IP address for the virtual machine, I can say. Then we have a running on intermediate server. So it is like HA proxy divided manage health check, removal and addition to machines, balance request for the post and polls. So after the hardware and software load balancer, the next topic we have a database, and in the database also we have a categorized two types of SQL and NoSQL. SQL is basically used for the relational databases and NoSQL is used for the non-relational databases. And for these two databases, we have to store the different data types. So we have to be keep in mind which data type have to be used for the SQL purpose, which data we have to be used for the NoSQL purpose. We have to be take the difference between them. In the relational database, always have the data in the structure format. In this scenario, we have to be idea about how the data will be going to store, what type of data we have. We know data format, this is every time fixed. So fixed type of data purpose, we have to be structured data. So that time we can use the SQL, and we don't know what is the data type coming from the end user. It is unstructured, so we can use the non-relational database. And as I mentioned, we have a predefined schema, and in this we have a distributed. Coming to the in the relational database, we are storing the data in the row and column format. Row is containing the one entity info and column containing the separate data points. And in this, the data is stored in the key value format, document DB, white column DB, and graph database format, I can say. And the relational database, we have MySQL type, Oracle, MS SQL Server, SQLite, Postgres, MariaDB, example of the relational databases. There is a lots of example, every company using as per their requirements for the data, these different databases. After this, we have to be when we reason to use the SQL DB, we have a scenario if you need to ensure that the asset compliance, most of the finance and banking organization, they are using the SQL DB. In this, we have to be asset compliance. It is reduce the anomaly and protect the integrity of the database. For many e-commerce and financial application, this asset compliance DB is the first choice. Second, we have to be when we have a data structure and unchanging, in your business is not experiencing the rapid growth or sudden changes, then no requirement of the more server, data is consistent, and then there is no reason to use the system designed to support variety of data and high traffic. And after the SQL, we have to be reason to use the NoSQL DB also. So when we have to be used, when all other components of the system are fast, then querying and searching for the data is a bottleneck. So NoSQL prevent data from the being bottleneck. And next we have a big data when large success for the NoSQL. To store large volume of the data, little or no structure, structure or not mix of type, low limit on the data type of the storage. And after that, we have a document DB, we are storing the files, format and all. Store all the data in one place. No need of type of data. And third option, we have using cloud and storage to the fullest. Excellent cost saving solution. Right now, most of the organization going to take the solution or services from the cloud one, so they don't have to take the risk or stress for this solution. What the data they are storing on the which location or whichever, they all take care of the cloud service provider. And no headache for the additional software, by the way. So NoSQL DB Cassandra right now designed to scale across multiple data center out of the box. And if in your system or in your requirement is a rapid growth or agile development, then if you are making the quick iteration on a schema, SQL will slow down. So for that reason, you can choose this NoSQL data. Dynamic type of data, I can say in the one line, you can go with the NoSQL. Static type of data and fixed type of data, I can say you can go with the SQL DB. So these two key components have to be choose when we are choosing the databases. After that, we have a CAP theorem. It is a very important factor while in the system designing. CAP theorem, as the name suggests, like C for the consistency, A for the availability, and third, T for the partition tolerance. So consistency achieved by the updating the several nodes before allowing reads. All nodes see same data at the same time. And availability means like every request gets response, success or failure. Partition tolerance, like system continuity work despite massive loss or partial failure. So this three component is a major part while creating the system design, and this all will be achieved by the some factor which we have to be designed, which we have to be keep in our mind. Availability we can achieve by replicating the data across the different server. Like if one data server is getting failed, we have one replication or another data server from the copy of the data server one, then we can continue to transfer our first one to second one data server. So it gives the like availability, no drop services over there. Partition tolerance can be achieved by like can sustain any amount of network failure without resulting in failure of entire network. Like microservices architecture, one of the example, when one service is getting failed, then other services not getting impacted, they are running, because they all the services have a different DB independently, they are isolated environment deployed, and data is sufficiently replicated and across the combination of nodes network to keep the system up. That's why in the partition tolerance is a major component in the system design. So it is impossible for the distributed system to simultaneously provide more than two of the three of the above guarantee. So we cannot build a database which is like continuously available, sequential, consistent, and partition failure tolerant. Because to be consistent, all nodes should be see the same set of updates in the same order. But if network suffer partition, update in one partition may not make it to the other partition. Like client read from data out of date partition and after having read from up to date partition. For that, we have a solution like stop server request from out of date partition. Server is no longer 100% available. So that's why this can like major important role while designing a system. And after that, we have a redundancy and replication. As the name suggested, redundancy and replication, like we are creating a duplicate data. So duplication of critical data and services, for that increasing the reliability of the system. So for critical services and data, ensure that multiple copy or version are running simultaneously on the different server, because if one server is getting failed, when we have a replication, for that we can get the availability or consistency for that request response purpose. Next, we have a secure against the single node failure. So for that, like provide the backup if needed. It's like this, you can see we have a primary server, and again if this is goes failover, then we have a secondary server. This all the data containing here also, then we can directly transfer our request to here, then the response is getting connected over there. And after this, we have a like data replication. So here we have a active data, here we have a mirror data. And service redundancy is like shared nothing architecture, I can say. Every node is independent, no central service managing state. So like no single point of failure we have to be checked. More resilient for the features, and new server addition without the special condition help in scalability. So this is the terms which we have to be using the redundancy and replication. After that, the caching. Caching is a very important major role in the system design. At the name suggests, caching is like caching. We have to use the caching because for the response and performance increasing due to this. And in this, we have to be achieved with the help of load balancing, like scale horizontally caching locally of reference principle. Like as the name suggests, we have to be like caching is like reference purpose we are using when the certain request is coming again and again, and similar type of data we have to be respond. So for that scenario, we don't have to go to the actual server we can create the layer of that server, caching server, which we are getting the response for the particular request. So placing a cache directly on a request layer node, local storage of the response. As you can see in the diagram, the request is coming in the request layer, it is going, and if any request is missing here, we have another server that is missing server, like miss server, and again we can get the miss server, like miss request data from this one. So this is from the like request coming, response is coming from this one. Then cache on request last node can be located as like memory and node local disk. In the memory, data is very fast, like requesting or responding, and node on the local disk is also fast compared to if the request is going to the network storage to traveling. So it is referred to like go with this node local disk. And after that we have a bottleneck. Bottleneck, like if load balancer distribute request randomly, same request different node. So more so in the distributed cache you can see we have a node 1, node 2, node 3, and for that we have attached the cache 1, cache 2, cache respectively. 1 to 4 requests we are designed and divided using the consistent hashing function. You can see 1 to 4 requests. Then you can see how the request is going from one node to another node, 1 to 2, 2 to 3, like that. And the request response is coming, and this will going to the end users. This means like if any data which we are searching, if not found in the cache 1, it goes into the cache 2. Similarly for the cache 3, if the data is found any one of them, then it responds to the end user. So it is fast retrieval of data and easy to increase the cache space by adding the more node. And disadvantage of this, like resolving a missing node, starting multiple copy of the data on the different node can be handled by this one missing node. So we have to be add one more node for the missing one. And even if node is not have, like if node is disappear, request can pull data from the origin. If we think like that request response what we have, if not getting in the cache server, we have the alternately original server when we can request from that origin server and send to the response to the end users. And after that we have a global cache. In this, like single cache space for all the nodes, like adding one cache server or file state faster than the original store. It's like difficult to manage if the number of client and request increases. So for that reason this global cache is a useful, and that will be performed with the help of like fixed data set that need to be cached and special hardware with there for some fast input and output operation. You can see we have this diagram for the global cache, how they are distributed. We have a two servers, this one and this database. All the server getting the request from this global cache, and this cache managed to bring the data from the database, and it is like contain the hot data set. Similarly for this global cache, we can see if anything we are missing from this global cache, then alternately we can get the data from this database original server. As a diagram you can see. So application logic understand the in function strategy and hotspot better than the cache. So yeah, you can see if this same request is coming here, if it is not found, it again goes to the original server and taking the response and send to the end users. After this we have a CDN. CDN is like content distributed network. It cache store the for site that serve large amount of storage media, static media. In the request you can see CDN containing request from the end user, and it's checking. If it is not available, it again return the request from the backend server, and if it is available, it is available from where we have a local storage static media file. So it's going to response from that local storage to the end users. If you are a developer, you know we in the JavaScript we are creating the local storage, session storage. So this all the storage mechanism is coming from this scenario or this thought process. If the sets isn't large enough to have it on, then CDN is a very good one for better and easy future transition. After that, we have a cache invalidation. Cache data need to be like coherent with the database. If data in the DB is modified, invalidate the cache data. So there's a three schemes. First, like write through the cache. In this, we have a data which is for the cache and which is from the DB. So data is written same time in the both cache and DB. So complete data consistency, cache equal to DB. Fault tolerance in the case of failure, data loss. So high latency in write to write operation. So for this is write through cache. And after that, we have a write around cache. In this, data goes into only DB. So no cache flooding for the write, like no cache we are writing or loading from the cache as in the write through the cache. So each read request for the newly written data miss, then higher latency. And last one, we have a write back cache. In this, you can see data is coming, data request coming in cache, then again cache goes to the DB. If it is not found here, then it goes to the DB, and after some interval or under some specified condition, data is written to the DB for the cache, and this same request from this cache, it is taken from the DB, then this DB contains the data and cache will store, and this cache will send the data to the end user, respond to the client. So low latency and high throughput for the write intense application. So data loss only for the one copy in cache. So these three type of cache scenario we have to be create. And cache eviction policy containing like this mechanism, this entity, this list I can say. First one is a FIFO, second one is a LIFO, first in first out, then second we have a last in first out, then we have a LRU mechanism, LRU cache, MRU, LFU, list frequent, list recent, random replacement. So this is a cache eviction policy is used for retrieving response purpose data in the cache mechanism. After that, the sharding part is coming. Sharding part is nothing but we can say data partitioning. Data partitioning means like splitting up the data or table across the multiple machines, like manageability, performance, availability, and load balancer. With the help of this component, this data partition is performing. After a certain scale point, it is cheaper and more feasible to scale horizontally by adding the more machine instead of the vertical scaling by adding the higher different server. And how to perform the partitioning. So method of partitioning we have like horizontal and vertical. In the horizontal partitioning, we have a different row into different table, range based sharding. Like example, we have a storing location by zip. So in the table 1, zip width contain the less than 1 lakhs, and the table 2 contain the zip width greater than 1 lakhs. So different range in the different table. And cons, like if the value of the range not chosen carefully, then leads to the unbalanced server range when we are using. So we have to be checked properly. If that is not be taken, then it will be fallen down. So table 1 can have more data than table 2. Second, we have a vertical partitioning in which we can see like feature user distribution of data like in different server. In the Instagram example, I can say we have a DB server 1 for the user 1, and DB server 2 for the followers, DB server 3 for the photos. So all this 1, 2, 3 server we are having a different request of different entity purpose. So straightforward I can say to implement how impact on this app is getting from this vertical partitioning. If app is additional growth, like we know in the future the Instagram adding one more feature, for that purpose the request and response we have to perform, so we have to store the data for that. So in that scenario, vertical partitioning is an added advantage. Need to be partition feature specific DP across the various servers. For example, it would not be possible for a single server to handle all this metadata query for 10 billion photo by 140 million users. And after that we have one is like directory based partitioning. In this, like a loosely coupled approach and work around uses mentioned in the above the partitioning, like create the lookup services currently partitioning scheme and abstract it away from the DB access code. So mapping like tuple key and DB server. It is like easy to add DB server and change partitioning schemes. And for the partition criteria, the key or hash based partitioning we have to perform. Hash partitioning, like key of the data and hash function, then partition is a number, and efficiently fix the total number of services and partition. So if we add, if we effectively fix the total number of servers partition in the key or hash based partitioning, and efficiently fix, like we already seen in the picture. And so if we add the new server or partition, changes in hash function and document downtime because of this redistributions, and solution goes to be just this breakdown. And after that we have a list partitioning. In this list partitioning, each partition is assigned a list of values. New record is coming, then we have like lookup for the query and store the record for the particular list, for the particular record, for the particular value based on the key. And then after we have a round robin for partitioning. It is like uniform data distribution. Within n partition, the ith tuple of assigned to the partition I mod, and this is the logic, this is the formula for this round robin partitioning purpose. Then next we have a composite partitioning. In this, combination of above partitioning schemes like hashing plus list is equal to consistent hashing, and hash reduces the key space to a size that can be listed. And after that we have a common problem of sharding, like shared DB, extra constraint on the different operation, then operation across the multiple table or multiple rows in the same table, so no longer running in a single server. For that, the joins and denormalization is coming. In joins on the table on a single server, straightforward, not feasible to perform joins on the sharded tables because it is a less efficient. Data need to be completed or compiled from the multiple server. And workaround for that, we can denormalize the DB so that the query that previously read or join can be performed from a single table. And cons, I can say denormalizations like palace of the denomination of data inconsistency. Then we have a referential integrity like foreign key on the shared DB. It is a difficult. So most of the RDBMS does not support foreign keys on the sharded DB. So it is application demand referential integrity on sharded DB. So enforced to an application code or SQL join to clean up the dangling reference. So this is the like referential integrity containing the problem and difficulty, I can say. After that we have a rebalancing like reason to change the sharding schema, like non-uniform distribution data uses. Then we have a non-uniform load balancing request uses. So for this purpose the rebalancing is happening. Workaround we can perform for the balancing purpose: add new DB. Second, we can rebalance with the help of change in partitioning scheme, data movement, downtime. So we can use the directory based partitioning. In this, like it is a high complex but single point of failure also one of the case we can see in the lookup server table. Okay, then after the sharding mechanism is ended, then index is coming. Index basically we are using to perform the searching and querying as quick as possible of the particular table in the database. So it is like well known because of the databases, improve the speed of retrieval, increase the storage overhead, and slower write the data and update the indexes. So can be created using one or more columns indexes. Rapid random lookups like efficient access of ordered records. In the data structure, we have a column like pointer to the what row. So create different view of the same data. So it is like very good for the filtering, sorting. As I mentioned, it is like using for the query purpose. So basis on the filtering, sorting, this type of mechanism we can achieve with the help of applying the indexes on the column in the database. So no need to create the additional copies. Use for the datasets like TB in Science and small page load KB. So spread over the server, physical devices. We need to some way to find the record physical location like indexes. Yeah, and then proxy. Useful under the high load situation if we have a limited caching. Like proxy is used on that scenario when we have a limited caching. And this architecture, you can see how this proxy server is handling in the app. We have a client, and here we have a cache, and here we have a proxy server, and this is connected to our web, and web is connected to our backend server. So how this request is coming here from the client side, you can see. Then proxy server filter the request, log request, and transfer the odd remain headers, encryption, decryption, compression, request coordination. Basis on that filtering, the data request goes to the web, and this web sending to the backend server and getting the response from that. And before the proxy server, you can see we have this cache which is used frequently, use the request and resource purpose. So we can also use the spatial equality locality, which is like collapsing the request for the data that is spatially close. And in this, we can collapse some data accept requests into one. The collapse minimize the read from the origin. After that, we have a queue. Queue is basically if we use for the like manage request in the large scale distributed system, and in a small system write this fast, and in complex system high incoming load and indivisible write take more time. So to achieve this high performance and availability, system need to be asynchronous. So it is achieved with the help of queues. Synchronous behavior like daily performance. I can give this example. Synchronous behavior like grid performance can use the load balancing. The difficult for the fair and balanced distribution, you can see we have a client C1 to C4, we have a queue, and this all the requests coming from this queue. And you can see like if you are aware about the event driven architecture in this, how the request is coming and how they are going into the message broker. If you are aware of the cloud developer, then you have idea about like how we are sending the request from the queue and checking the request of the queue is getting processed or not. So similarly, that mechanism we can see from this architecture. The client request is coming in the queue format, and this queue is sending to our database server, which is going process or not. So message type of communication is basically processed with the help of queue. And queue is basically used for the asynchronous communication protocol. Client send the task and get acknowledgement from the queue recipient, same as a reference for the result in the future, and this client get continue to work. And limit on the size of the request, like number of requests in queue, there is a limit also, like how many requests you can send. In the Azure cloud, you can see we have a request like how many 200 or 250 requests you can try, or 100 requests you can try. Before that, you get the TLE, time limit exceeded, some exception over there. Then we have a provide the fault tolerance on this with the help of queue. Protection from the services outage failure, highly robust, retrieve failed request or service request, and it is like enforces the quality of services guaranteed, does not expose the client to outage. And queue is like distributed communication, so open source implementation like RabbitMQ, ZeroMQ, ActiveMQ. These are the example with the help of queue, which is Azure. And after that, we have a consistent hashing. which is achieved with the help of hash table. Distributed hash table is like we have indexes over there, and that hash function is a key. Suppose we are designing distributed caching system with the n cache server, then hash function goes to key mod of n. Drawback for this consistent hashing, it is like not horizontally scalable. Addition of the new server result in the need to change all the existing mapping. Downtime of system. And second, we have a not load balance because of the non-uniform distribution of the data. Some cache hot and saturated, other cache is ideal and empty. So that's why they are not they don't have a load balancer. We are not supported the load balancer. How to tackle this above problem? With the help of consistent hashing. So we have to know basically what is the definition, what is the main objective of consistent hashing. It is like very useful for strategy for distributed caching, minimize the reorganization in scaling up and down. Only k mod of n key need to be campus, like keys are like total number of key and is the number of servers. And how it works, typical hash function. Suppose output in 0.25 sequence is consistent hashing. Imagine like all of these integers are placed in a ring from 0 to 1 and 253. We have 3 servers A, B and C. Twin like given a list of server, hash them to integer in the range. You can see A, B, C, this is the range we are created, and map key to a server, hash into the single integer, move clockwise to find the server and map key to that server. This you can see clockwise from this 0 to key -1, then key to this one last. And adding a new server D will be resulting moving the key to B. You can see we are adding one of the key, then we have to move the C server to the nearby this. So removing server A will result in moving the key 1 to B. Yes, you can see this, we are removing from here A. So it like consider the real work scenario, data randomly distributed and goes to unbalanced cache. So how to handle this issue? This is vertical replica. Instead of mapping each node to a single point, we map it to multiple points I can say. So more number of replica, more equal distribution, good load balancing. You can see this is the right approach, the right diagram for the final stage. After that, we have a long polling versus WebSocket on server sent events, and this is like client server communication protocol. First we have a HTTP protocol. This is normally request is going to our cloud and the response is going to the end user from the server. Prepare the response for the request coming. And after that we have a AJAX polling. Client repeatedly polls server for the data, and similarly to the HTTP protocol, request sent to the server at a regular interval 0.5 seconds. This was the example. Drawback: client keep asking to server new data and lots of representation of the empty. Like you can see in the diagram, we have a continuously coming the request, this one, and HTTP is overhead, and this request getting a response, this getting a response. HTTP long polling, like hanging with the get, like server does not send the empty response, forces a response to the client only when the new data is available. Then we have a client made HTTP request and wait for the response. Then second, we have a server delay response until the update is available or until timeout occur. Third, we have a update server send for the response, and fourth, we have a client send to the new long poll request. client send new long poll request. So yeah, we have two types here. Immediately after reviewing the response, the after a passes to allow acceptable latency period. And each request has a timeout. Yeah, so client need to be reconnect periodically due to the timeout. This you can see, this is the breaking. So this is happen for the timeout scenario. Okay, then we have this WebSocket, very important concept. It's like full duplex communication channel over the single TCP connection, provide persistent communication. Client and server can send data at any time. So bi-directional communication in always open channel. You can see in the diagram we have a client and server. This WebSocket handle the request, and the request response is coming from this one, and always open for the bi-directional. The mobile phone, when we are right now talking, this is happening. This is the working under the TCP protocol. One communication when one person is communicating to another person via the phone call. So it is a lower overhead real-time data transfer. Then we have a SSE. SSE is nothing but server sent event. In this, client establish the persistence and long-term connection with the server. Server uses this connection to send data to the client. If client want to send data to again server, require another technology or protocol. Data request coming here, then using the regular HTTP. Again, they have to be send the response. So for the response, whenever new data is available, it's sent into the client. So best when we need real-time data from the server to client. No still data. Every time new data is coming. Like live streaming of the cricket match, you can see that is a best example. So this is till now what we cover. I think most of the topic we cover in the system design. Hope you got the better idea about how the function is working, how the design is working, how the catching is working, what is the mechanism, what is the tools we have to be keep in our mind. So thank you for this listening. Meet you in the next video.